Okay. So in the frequency bands, we are going to be totally looking at various, and one of the major key objectives of this course, we intend to be describing the various concepts about the wireless frequency bands and the channels, but also we shall look at the various regulations that are being used on the wireless local network frequency bands and the channels in different countries. Later on, we shall also list the devices that are being used within the wireless network. So we shall start with looking at the various frequency bands and its channels. We shall be able to talk about the ISM band. The ISM band is mainly for the industrial, scientific, and medical band that is used on radio in order to be communicating internationally. Most of the radio frequencies here, as they are used in the medical or scientific fields, they are typically being defined by what we call the Federal Commissions Commission, which works in the United States of America. For the industrial band, there is a range, okay? And because the FCC works with a couple of agencies across various countries in the world in order to implement what we would call the licensed and the unlicensed bands. So it's key important to know what ranges are being recommended and in what countries. The industrial band in America will range from all normal ranges from 902 to 928, and in Europe it ranges from 900 megahertz frequency band normally for the European countries. So depending on the country, the band ranges will differ. For the industrial band in America alone, there's 902 to 928 megahertz frequency band. But for the European countries, for them, they use the 900 megahertz frequency band that is used for also GSM, because GSM has 800, 850, but also partially uses the 900 band. Later on, we shall look at those various bands. But yesterday, we also discussed about these bands that are used in LTE. We discussed about the 2600, but also we discussed about the 2100 that is being used partially for UMTS and also LTE. We discussed about the band for UMTS, which we said it was 900, but partially also shared by the GSM network. Mainly we have the 950 and the 1900 used for the UMTS for that category. 1800 is also there, which is used for the LTE for that matter. Then for to talk about this industrial band just a little bit, it uses the frequency band of 2.4. The devices, in order to avoid the interferences among those communications, the devices use the 2.4 gigahertz frequency band in order to avoid the interferences. For the frequency of the scientific band, it ranges between the 2.4 gigahertz for all countries. Most of the countries, the scientific band is the same. They range at 2.4 gigahertz, and this includes all the usage of all your Bluetooth, the Zigbee devices that all have that capacity of working at the 2.4 gigahertz band. The range is 2.4 to 2.48, 8 close to those gigahertz for 2.4 to 2.4835 range. Then for the medical here uses a range of 5.725 to 5.875 gigahertz. This is a question I have seen somewhere. I think we shall list out some of the key important areas that are being seen in question areas of the certification exam rollout. So this question is being seen there, talking about the range. What is the range? Actually, the main key difference or the main factor here is in these numbers. These numbers look similar. The 5.725 and the 5.875. Most of the people confuse them, and they can just play around with the numbers to make you confused. But the range is 5.725 to 5.875. So those are the basic ranges that also give another range of 5.15 to a 5.35 gigahertz, but they all run at a 5 gigahertz band. Okay, and the 8.802.11 standard supports both the 2.4 and also the 5 gigahertz frequency bands that matter. We have a couple of channels that can be used for various technologies. For example, when we talk about the standard for 802.11b G or N, we can specify out the specialization of each using the 2.4 frequency band, but also we can't leave out the channels or the number of channels. In each of these technologies, we have what we call overlapping channels, and approximately we have 20 megahertz carrier channels that are being used as the overlapping channels. That's the how wide each channel is. And actually, the 2.4 gigahertz band is divided in 14 overlapping 20 megahertz carrier channels. And in the US alone, all of these channels are available in the US. Other countries have 13 channels being used, like in the Europe, the channels range from 1 to 13 channels. Actually, in America, the FCC, the Federal Communications Commission, ruled out to only provide 1 up to 11 channels, and Japan uses the entire 14 channels in Japan. China uses up to 13 channels, and we shall look at all of these in a bit to come. We have technologies like the 802.11a and the 11n, which are specialized using 5 gigahertz, and their channels run at 5 gigahertz. These ones really are also divided depending on the various countries there. So for the 2.4 gigahertz frequency, it is much more used and widely used. For example, if you look at the 802.11a, which uses the 5 gigahertz band, it has the features of low channel conflicts. So it is much more recommended to be used because of its low conflicting channels. And however, the high frequencies also in that regard are easily absorbed, and it has shorter transmission distances compared to the 2.4 frequency band. So that is what normally is being looked at when you're considering whether to use what channel or what channel for aperture technology. We have a table that can entail the details of the entire technologies. This table comprises of which year was the release of the technology, how much bandwidth, what is the frequency, how many non-overlapping channels are in each of the technologies, and the modulations that are being used by each of the technologies and their speed rates. Now, this table, in addition to the table that we looked at yesterday, these tables are so much important if you are to grasp the technologies of 802 standards. It tells you of the speed rates, the modulation technologies, the non-overlapping channels, and the frequencies. So if we are choosing one of the technologies, for example, let's start with let me just pick out one of the technologies. For example, 802.11b technology, which is one of the standards that are being much used. It operates at a 2.4 gigahertz frequency band, and its transmission reaches up to 11 megabytes per second. This technology is so much well known as a standard. That's why it is much more used, and it has it provides you 14 channels with a bandwidth of up to something like 22 megahertz. But if you are to compare it with the G, the 802.11G, you'll find that the 8.02.11g operates also at the 2.4 frequency gigahertz frequency band, and has data limits of up to 54 megabytes per second. It has got the actual transmissions of speed, the actual transmission speeds, because we have what we call theory speeds, but also we have the actual that run up to 24 megabytes per second if it is using 2.4 gigahertz frequency band. So there are many devices that are compatible with this technology, which includes all the devices that work with 802.11b, because G was made as a compatible or as a compatibility technology with the latter technology of B standard. It uses, much of the time, it uses various technologies in order to provide this backward compatibility. And one of the technologies it uses the CCK technology. You can see these are some of the modulation technologies being listed out here in order to support, because previously the 802.11b was using CCK and DSSS. We shall look at these ones fully in detail later on, as we exploit all the information about the modulations. So to make G compatible with B, it must also have a similar technology, and that is the CCK, and also uses OFDM technology, which is the orthogonal frequency division multiplexing technology, in order to do good modulation. The other technologies are already listed here, but also to note there are technologies like the 802.11n technology that can provide a maximum speed transmission rate of up to 600 megabytes per second. And this can really provide you with high transmission rates that can reach the speed we have talked about, which is 600 megabytes per second. And this can really provide you with high transmission rates that can reach the speed we have talked about, which is 600 are being achieved because of the technology they use at the all the modulation technology that is being used, and it uses what we call the MIMO technology, multiple input, multiple output technology that provides that high transmission, those transmission rates. So the moment you grasp the table here and the table we saw yesterday, actually the table that we saw yesterday is also included in this very table. So this would help much more because it has the inclusion of what we are talking about all entirely yesterday. So let's look at each of these frequencies, and we shall start with the 2.4 gigahertz frequency band. We shall look at the various channels. We shall look at how much overlapping channels are there, and the size of each of the channels in terms of bandwidth. So we shall start with the 2.4 frequency band. This band supports a couple of standards. Supports 802.11b, G, and N. 2.4 gigahertz as a frequency band occupies or avails with 14 channels, but each of these channels occupies approximately 22 megahertz bandwidth. But for the G and the N standards, for them they occupy 20 megahertz bandwidth, and that makes it to be completely compatible with 802.11b and G technologies for the standard of 802.11n. Though there are some of the theories that come out and say this technology is not compatible fully, like here, that is illustrated within the HUAWEI literature, because of certain challenges. Remember, the 802.11b uses CCK as a modulation and also uses the DSS. But 802.11n technology uses the MIMO technology. Now, there is a challenge that comes up with this kind of modulations if they are going to be compatible with the other technologies, which is not sometimes mentioned in some literatures, though it is understood that it should be compatible, because the main reason for creating the 802.11n standard was to provide that backward compatibility with all the technologies that were there before it. Okay, so that is the other issue to take note of. These frequencies work in various countries, and each country has got its own frequency bands and channels. For example, when you look at the channels, because we said the 2.4 gigahertz frequency band gives you up to 14 channels, but only 13 are being used within the United States of America. Actually, 11 being used in the United States of America, and then China uses 13. Japan uses 14 channels entirely, and giving out the 14th channel to 802.11b only to use. The rest of the other standards can use the other channels, but 14 channel is given out only one standard. Australia also uses 13 channels. That is how to say of these various channels being used in various countries. So those are the ranges of the channels being used in various countries, and because of the agencies in those countries. For example, in America, we have the Federal Communications Commission, the FCC. Canada has IC, and also Europe has its body that we've looked at already, which is ETSI body. I've already given out various ranges for these frequency bands to be used according to the authorities in those countries. So we bring up to the point of channel binding, because once we have the 14 channels, we have a very big problem of interference. So there is what we call channel binding, which is a technology that helps to bind various channels or neighboring channels that are 20 megahertz, to bind them to form a double transmission rate. For example, if you bind two channels that have 20 megahertz, or that occupy 20 megahertz, that means you form one channel that has 40 megahertz, because 20 will be doubled. So for these wireless technologies, when the two channels are being bound together, the throughput will be largely increased. And for the standards of the 802.11, those air interfaces will work, okay, at a given bandwidth rate, which is originally 20 megahertz for each of the channels. And now we have what we call the binding technology, that's going to bind all the neighboring channels to form 40 megahertz channels for that purpose. So these channels can be binded together and then also be separated if there is need. And one of the primary key purposes for binding is to form what we call primary channels, and also what we call the secondary channels. So if you bind two channels, they will form what we call the 40 megahertz channel, and that can be used really to transmit and receive data at high speeds. Partially, the bandwidth might be reserved sometimes using the 20 megahertz channel, and that will help a lot in avoiding what we call the interference. So these two channels, once they bind or they are bound together to form a 40 megahertz channel, it can also be reserved and used for communication later on to improve the throughput. So that's about the 2.4 gigahertz frequency band. Let's look at what is found in the 5 frequency band, 5 gigahertz frequency band. For the 5 gigahertz frequency band, mainly it supports also the technology of binding the 20 megahertz, because the 802.11n that works well also with the 5 gigahertz, because remember 802.11n can support 2.4 gigahertz and also supports the 5 gigahertz. So that means it is able to support the binding of these various channels that run at 20 megahertz to form 40 megahertz. Though the higher technologies like the 802.11sc supports much more than that. It does not only support the binding of 20 megahertz channels, it can support binding of more and more. For example, you can bind 20 megahertz to form what we call 40 megahertz, but also that can be binded to form 80 megahertz, and also that could be binded to form the 160 megahertz band of non-overlapping channels. So this increases the bandwidth and also makes the communication have no interferences at all whatsoever. So the table here is just showing you the various frequency and channel IDs that work in various countries, and also stating whether they work outdoor or indoor. China has gone ahead to divide some of these frequencies and channels in order to be working for outdoor and also for indoor. So that is the chart indicating the frequency band and also the center of these frequency bands after they have been, because the frequency band here shows you when they have binded some of the channels, and here just shows you this lane just shows you how the middle frequencies of those that have been already binded, and showing you the channel IDs of those. So in China, this table illustrates that in China, 5 channels have already been provided for 125 megahertz in order to provide the center for the outer channels that give you 20 megahertz to perform all that work at the edge of each frequency band. And in America, using the FCC, it has highlighted out 8 channels that provide you with low frequency bands, and also those channels give you middle frequency bands totaling to a totality of 200 megahertz. So 4 of these channels will provide high frequency with a total of something like 100 megahertz, and also being put at the center to provide 30 megahertz, which will work at the edge of each of these frequency bands. So the uni totally will provide the high frequency bands, which will always cover a distance of up to 20 megahertz, as illustrated for each of the bands out there. So typically for China, the 5.8 gigahertz channel is much more reserved. It is much put into what we call the non-overlapping channel, and it is being used in China in order to do operations. So there are 5. Remember that China has reserved 5 non-overlapping channels, and the 5.8 gigahertz frequency band is one of these. These channels have IDs that correspond to 149, 157, 165, 153. Also, we have 161 channel ID there. So if you are brought to a range, I think you can see within here. You can see when they talk about these channels, we have the 149 channel, there is the 153 channel, there is 157 channel, there is 165 channel, and the 161 channel. These channels entirely are being used, or the one of the non-overlapping channels that work at the 5.80 that is how the 5 gigahertz center frequency band is being used within China for that. Then we have the channel binding. We have what we call the channel binding. Channel binding for the 5.8 gigahertz. It is normally a 40 megahertz channel that has a high usage of efficiency and frequency for the band that is used now to be doubled in order to double the output for the 20 megahertz channel mode. Though when you have these 40 megahertz channels, there are some problems being experienced on these channels, which is much of it is a limited spectrum resource regarding the 2.4 gigahertz band. Remember, the 2.4 gigahertz band used to have 20 megahertz and they could be doubled or binded together to form 40 megahertz. But as they come to all these ideas being brought to the 5 gigahertz, there is a great problem that can be experienced, which is the limited spectrum resources to be used there, which cannot provide you with 40 megahertz. So the 5 gigahertz frequency band, for it has got various or numerous resources to be used for the spectrum, and the FCC have come out to put out it clear that there will be 23 non-overlapping channels that will be used, but China specifies out only the 5 that we already looked at previously in the previous slide. Only 5 of them are to be used within China. So that means this will provide great supply of resources that will be used to bind these 40 megahertz channels. And each of these 40 megahertz channel should not be binded with any other frequency band of a 2.4 frequency, because there will be those challenges of resources. So the 802.G and /N technologies obtain much more channel resources to be used for the cellular signal coverage. And this makes it much more better when the 802.11n frequency band supports the binding of both 20 megahertz and also having a capability of supporting the 40 megahertz channels. And because of this, we can say that this technology can be transferred to the 802.11sc technology, which will support much more binding. It can bind the 20, the 40, the 80, and also up to the 160. So that is it for the binding for the 5.8 gigahertz. And we can look at the non-wireless devices. These non-wireless devices include devices that are not that much connected with cable. Okay, so for the 2.4 gigahertz frequency band, there is an ISM that is being used as an open frequency band. Devices will have to start working with the 2.4. We already talked about the 2.4 gigahertz to support Bluetooth, to support all these ranges of devices that work within this technology of 802.A, B, G, all those technologies. So compared, we have devices like baby monitors. We can see them. We can have baby monitors. We can have radars. We can have wireless cameras. All these devices work at the 2.4 gigahertz. But if we have to put a comparison between the 2.4 frequency band and the 5 gigahertz frequency band, there is less interference with the 5 frequency band compared to the 2.4, because many devices are in that space of the 2.4 frequency band, and few of the devices can really use the 5 gigahertz because it is extremely one of the extremely high frequencies. So more of the devices begin to use the 5 gigahertz band, such as there is a cordless phone here that is also now having a capability of using the cordless or the 5 gigahertz. The ladders have also started to use the space because there is need to free up some space that is much more congested for the 2.4 frequency band, and yet there is much more space within the 5 gigahertz frequency band. So that is how we extend the 2.4 frequency bands, by putting some devices to use the space of the 5 gigahertz. So that is it for this chapter. There is a simple quiz here. There are two questions. First question is talking about what are the common non-overlapping channels that work at the 2.4 frequency band. Anyone willing to answer this? Question number 1. Okay. No one is willing. All right. Yes, Nasa. Nasa, you can unmute yourself from that side.
1, 6, and 11.
Okay, there are 3 channels. There is channel 1, there is channel 11, and also there is channel 6. Yes, that's right. Question number 2 is just talking about the number of non-overlapping channels that are being provided by for the 5G gigahertz frequency band within China. We have looked at these. There are 5 channels. These channels include the 165, the 153, the 149, 157, and also the 161 channels. So those that is much to talk about. Within the frequency bands. So in the summarizing, we have talked about the 2.4 gigahertz frequency band, the 5 frequency gigahertz band, and the non-wireless devices for that matter. So that is much of what we had to talk about in this chapter. Unless you guys have questions. Any questions?
Previous question.
The previous question? Yes, Andrew.
Solution.
Andrew?
Previous question. Yes.
Which question? Question number 2, number 1?
Question 2.
I've already answered this question.
I was going to put a charge on my machine.
Okay. We have already looked at these channels, the 5 channels. We have 161, 157. We have another channel that is also known to be as the channel of 165, the 149, 153, and the 161 channels. So there are initially 5 channels that are being used in China as the non-overlapping channels for the 5 gigahertz frequency band. Yes, Musa? Musa, you can animate from that side.
Yes, you've talked about binding, but I've not understood properly. How does it work? Doesn't the frequencies interfere if I join one frequency with the other? If I join one channel with the other, doesn't the frequencies that are supposed to be following this channel interfere with the frequencies of the other channel, where there is some mechanism that's employed to such stuff? I don't know about that.
Okay, thank you, Musa.
Excuse me.
Thank you. Yes, Emmanuel, I'll answer that.
Daniel, what is the significance of these non-overlapping channels when you are designing a wireless network?
Okay, what is the significance of the non-overlapping channels? All right. I'll start with Musa's question about the if you bind the channels, will there be some interference because you have binded the channels? No, there won't be any interference. Actually, binding of the channels helps you increase the bandwidth of these channels. And because you're binding them and making them as one channel, necessarily it won't bring any harm. So this technology of channel binding is just binding the two channels or various channels that are just neighboring to each other to form one channel. And once these channels are bound together, the throughput will be realized and will be really high for those channels. And that means we shall have an air interface that will work at a really high bandwidth for a single channel. That's why there were 14 channels, but now only 3 being put in use, 1, 6, and channel 11. So you can see there cannot be interference there anyway. Then for, I think it was Emmanuel, was asking about the significance of the non-open channels. We consider them to be the channels that are not going to be that are going to be used in the wireless technology to avoid all the interference that would have been caused barely by the channels being next to each other. So if you have 14 non-overlapping channels, so that means these channels can barely have interferences. And later on, we shall be looking at how to avoid these interferences of various access points pointing to each other, broadcasting the same channel, different channels being propagated in another lane where the same or a similar channel is being propagated. So we shall see all this and how to avoid it. But the non-overlapping channels, typically, they should be giving you access and availability to the service without interferences. And that's their main purpose of the non-overlapping channels. Unless there are any other questions. Okay, so we shall look at the next chapter, which is basically talking about the various products used within the network, the wireless networks. So in this chapter, we are going to look at the various products. And these products, we are going to describe the wireless products for HUAWEI, and also look at the various applications of these products here and the various scenarios. So we shall also look at the power supply modes for these products, because we need to know how we can really connect them to power for that matter. So we have a new technology that's called the Power over Ethernet technology that has various modes to connect to various devices. So we shall explore all that. By the end of this chapter, we shall be knowledgeable about all that content. So let's start with the wireless products family for Huawei. These are some of the products and devices that are being seen on the market, that are ready right now on the market by the Huawei vendor, as a vendor. So in the wireless category, we have what we call access controllers that are being used to control all the access points on a network, and also have the access points themselves. These access points are divided into two categories. We have indoor access points, and also we have outdoor access points. The other category of access points is what we call the specific access points that are much more recommended for highly density rooms and complex wall structures that have challenges. These are the ones that are recommended to be deployed in hospitals, hotels, meeting or office meeting rooms, and all that, because they give you a good coverage for the various areas that I've described above. We shall later on see the agile access points and the deployment, and I think we can share a video about that, the deployment of the agile access points. But so far, let's first look at these products, each of them, and then we see how they really work and where you can really use them. We have the category of the SCs. We have the first SC, which is the 6005, SC 6005, which is managed, or it can manage a number of access points, starting with a range of 4 access points up to 128 access points. It has a capacity of approximately 4 gigabytes per second. That is for forwarding mode, and it can really hike a number of devices to give you better performances. It can create what we call the extended service set identifiers. Later on, we shall come to describe what is a service set ID, or what is a service set ID, what is an extended service set ID, what is a basic service set ID, and all that information. We shall look at it later on. But this access controller can give you availability of using 2K performances for each of the users, and also has that power port for inserting the power over Ethernet power supply. It has got 4 ports for power over Ethernet, and can supply up to 8 ports if you have various connections that you want to give its supply for the power. For the management, you can manage this device here by use of the eSite, but also you can use command line. We already talked about eSite. Did we talk about eSite? No, not really. But eSite technology is a platform that is used by Huawei. Actually, it is designed by Huawei to manage devices on a wired network, but also on a wireless network. So we shall talk about the eSite and see how it really works out to make life better when you're managing your network. And it is recommended, much more recommended for small networks or enterprises to be used, or to be to help it for management. There's another device which is the 66000 or 6605. For it, it can give you up to 10 gigabytes per second in forwarding mode. Okay, that's a good speed. But there is a monster access controller which gives you up to 40 gigabytes per second in forwarding mode, which is the SC2. The SCU2 is much more big in capacity for supplying, which gives you much more better speed. Now, this is also one of the key factors about this device of the ACU2, because it can only be installed when you have certain devices on your network. For example, if you buy this device and you don't have a switch that is having either 9700 or 7700 capabilities, this AC will not be working for you. Yes, Diana?
Yes, Daniel. You talked about east side. I didn't get you. My network was bad.
Okay, yeah. I'll explain much more better. I'll give it to you, the entire explanations. But eSite is a technology designed by HUAWEI Technologies, and it is much more used to manage your network. It can do planning for it can help you in planning for your network. It does management, but also is very good at monitoring. So most of the people use it for remote testing and also remote monitoring, whereby if you're a network engineer for a certain organization, it gives you that capability of monitoring your network remotely without having to visit the network physically for you to be able to make changes on your network. So that is the eSite. I'll give you much more of the information later on, and we shall see how it all works out. Then for the part of the SCs, we have what we call a native SC card, and this is much more used in large networks. This native SC card, the native SC card comes in what we call the X1E series. I think we shall visit that part later on. I'll show you the card modules there within the later slides about that. But I'm just giving you a nutshell about each of these access points. We shall see much more information about them. So this card helps you to connect to various switches so that you can supply your access points with better connectivity speeds. It gives you a speed of up to 1 terabyte per second in forwarding mode. So it's one of the most powerful access controllers right now on market. Because with this technology that we are revealing today in this course, it comprises of the most current wireless technologies that have been discovered on market right now. It is dominating, and most of the vendors have not really recovered from their earlier and previous discoveries with these technologies of the wireless technologies. So partly, when we talk about the access points, we can start with the indoor access points. We have various of them. The indoor access points, there are varieties of them, but they have very many or various differences how they differ. Most of the access points that are indoor have these two characteristics. There's an access point that has external antennas, but there is also there's also an access point that has internal antennas. Probably as an engineer, depending on your environment, but we recommend that you use access points that have inbuilt antennas for the corporate environment out there. So for the corporate world, you deploy access points that have inbuilt antennas to save you the burden of forgetting or having to fix the antennas after you have mounted these access points and all that. But for certain scenarios, we would recommend you to have the one for the outdoor, especially if you have problems with your coverage, network coverages on site. So I'll pinpoint about one access point, which is normally used right now on market, which is the 5030 DN access point. It uses the MIMO technology and can give you speeds of 1.7 gigabytes per second. It's a common one that you can see in offices, you can see in banks, you can see in hospitals, and gives you really robust network support. This access point, as we have said, it has what we call the MIMO technology. It's a 530, and it gives you good speeds that are being used for the connectivity. Elsewhere, this access point can also have higher. Yes, that's
Daniel, I have a question about the indoor access points. Okay, so when you place, I have a question about the indoor access points.
yes.
So, okay, from the knowledge I know is that when you place indoor access points outside, they're affected by weather, and within like a month, they'll leave down. But then, if you place these access points, these indoor access points, let's say in a shade, you've seen like how you get out of a building and you find a shade. Will they still work for like the lifespan they are planned to, or you have to put them in the building?
Okay, thank you, Dan. These access points are built specifically for certain purposes, each of them. And we wouldn't want to test an indoor access point working outdoor, because we know it will not manage the environment because of the harshness of the environment. The normal way of building this access point for indoor is not much built for wind effects, or even heat effects, rain effects, and all that. So typically they're built to work in a very cool environment, which we expect to have indoor. Then for the outdoor, they are really built in an aggressive way to handle their aggressive environment outside, whether it is sunshine or whether it is wind, whether it is water. These outdoor access points will work well. So we really wouldn't want, and if it's for shade, because the way the shades are being built, you can use outdoor and the network can just reach these shades inside, even pressing the access point within the shades.
Right.
All right. Necton, do you have anything to say? Because I mute you and you unmute. Do you have any question? Necton, are you there? Your network is really poor. I cannot hear you. Maybe you can type your question in the chat. All right. But there are other access points which can be used to mount on walls of indoor. We have like the AP2030 DN, which can be used for mounting indoor on walls. And also this one is much more used. But now the current technology is the newest one to exploit the wireless signals very well and have a good experience. You will have to use one of the latest ones, the 7030, which gives you what we call smart antennas that can be easily adjust the network capability in case you are getting out of range. Yes, Diana?
Yes. My question is, how do you mount these access points? Do you mount them on the side of the wall or in the ceiling? Because based on how the signals. Okay, based on how they propagate in let's say omnidirectional or in a specific direction. I'm asking like how do you properly mount them so that you can fully utilize this, like everybody, cover everybody.
All right, thank you, Dan. That's a good question. I think I'll explain this question of mounting. I'll get you a video. Just going to give you a video about how to mount the access point, and I think that will help us see how. But there are two types of antennas that work indoor: the ones that you can mount on the walls, and the ones that you mount on the ceiling. Okay, because due to some access points being heavy, you cannot mount them on the ceilings because we know some of the ceilings do not have that much capability of holding much weight. So we don't prefer or we do not recommend you to mount them on walls. I mean on the ceiling. So we recommend you to mount them on walls. And actually, these access points have specifications. Like you look at the AP 2030. This AP here. This AP here is a 2030 AP, and it is having a specification. It has specifications of wall mounting. Not recommended for ceiling, but this category of access points, these ones here, the 5030 and the 7030, for them you can mount them on ceilings because they have a lightweight and they are much more simpler to mount there on the ceiling. So that's where the differences are. For the most of the antennas that have the external antennas, the access points that have external antennas, they can be much more working on the walls. You can mount them on the walls, and also some of them, if you don't mind, you would mount them on the ceiling. But because these antennas, external antennas, have some weight that add on the access point, we don't normally recommend you to mount them on ceilings. But also they look weird when you find an antenna that's mounted to the ceiling and has actually when you find an access point mounted on the ceiling and has antennas that are external, it doesn't look really nice when you look at it. So it is much more recommended that you mount these ones on the wall for that purpose. Then for the outdoor, you can mount them on the wall or you can mount them on poles. You can really erect out a pole and then you mount them there in open air. And then you run fiber optic cables to that pole underground and you make connectivity to that access point in order to give you network connectivity. So that's what happens when you're mounting these access points. We shall see most of these as they are mounted. I'm going to show you a video of how they are mounted and how everything works. But we need just to go through each of these to show you the various capabilities of each of these devices. For example, we started with the AC6005, which has a good capability in managing a couple of devices. It can have a number of extended service set IDs of up to 1,000. Just imagine creating a network and it can connect a wireless network of approximately 1,000 other access points together. You can just see that it can manage all that. Because what we call the extended service set identifier is when you have the SSID that is similar and is being connected or interconnected. I will illustrate this by just doing this. For example, I have this as a service set ID, and also I have another service set ID. There is another service set ID having the same name, okay? having the same name, connecting everywhere on the network to extend the network or to extend the wireless network. What we call a service set ID that is extended. This is what we call the ESID. These areas here, they are the extended service IDs. So it can support 1,000 of these areas if you are connecting in the various areas using access points. So it can support really 1,000 up to 1,000 of those areas for you to extend your network connectivity. This can be used in public areas like city parks. You can use it for campus networks, hospitals, hotels that really connect large buildings for that matter. All right, it can connect up to 2,000 users per device, each of them. So, for example, you have already connected 1,000 extended service IDs. You can have 1 or 2,000 devices connected in those areas, and this one device can really manage all of those devices. Just imagine how many devices are really connected to various universities on those wireless networks there, because every student comes with their own device. Let's imagine a student having their own laptop, having 2 phones, because most of the people these days carry more than 1 phone, and all these phones are smartphones. So basically, each of the students can have a minimum of 3 devices connected to each of the access points. And really, you can see how much bigger this network can be in a particular day during the course of the week. So this device can be used to connect all those access points across the network platform. It has got power over Ethernet ports, which are much more used. And then for the east side, it gives you that capability of connectivity. The other device is the 6605, which gives you a higher capability than the other, because this one can hold up to 10,000 access devices for each of it. So this device, as you see it here, it can support up to 10,000 devices connected on a network, and it has a maximum number of IP addresses that can give you a pool of up to 16,000 IP addresses, which is a very big number. And we can say that if you're talking about 16,000, that means you're dealing with a class B or a class A kind of address to that. It can support, that's why it can support small to medium enterprises. And this is one of the big access controllers that can support large networks, and for which it can support users of up to 32,000 devices connected on your wireless network. It can support, or it can control, approximately 128 to 20 or to 2,048 access points. One device as it is, the SCU2 can support approximately those number of access points, and can hold or can support 32,000 users connected on that network. It has the capability of having a port of the console, which is the RJ45. That means you can connect to RJ45 and configure this device, and gives you the management ports of 1 gigabit port, and the USB port, and the auxiliary port for that matter. That means this device, looking at the specifications, it comes with 4 gigabit Ethernet ports. 1 port is for the network management, but the 3 of them can be reserved for service ports or connectivity. It can give us speeds of up to 40 gigabytes per second. One problem is that you cannot use this device if you do not have this category of switches, the switches of the S12700 switch, or the S9700 or the 7700. You must have these ones on your network to support or to be able to use this kind of card of these devices. We have what we call the native SC card. This native SC card is a card that you can buy and insert within the SCU device. For it gives you a support of up to a couple of users. It can give you users depending on the switch that you have on your network. It can support 64,000 users if you have a switch of the 12,700 series. But if you have this other switch of the 7700, it can support with the 16,000 users, and also giving you 32,000 users if you have the capability of having a 7900. It supports normally only large enterprises, because you cannot buy such high capability switch when you're going to support a small business, and it's highly expensive for the organization to spend money on that. So the access points also that it can support depend on which kind of switch that you have. If you have a switch that is 12,700 series, it will support approximately the maximum of 4,000 access points per card that you insert. So it's just a card, you buy a card, insert it into the SCU, and then you're good to go with all that. But depending on what series of switches you have, it will support. Now, the names of these devices, as you have seen them, this is the access points before I had mentioned. You have APs. Each of the numbers here has a function. As an engineer for the wireless network, you should just look at the name of the access point, and you know which category does it fall. Does it fall under outdoor? Does it fall under indoor? What are the capabilities of that access point by just looking at the number of that access point? For example, we have an access point here. Let's choose this access point, the 6050 access point. 6050 access point is AP6050DN. So let's see. 6050DN. I'll write it here. AP60 50 DN. Okay, that is the 6050 DN. So by looking at the number of that access point, I can just say six lies here. So that means that is an indoor. That is an indoor access point. By just looking at 6 here, I just have to follow here, meaning that is an indoor middle. It supports only middle or medium enterprises and has a high density. The 0 means whether it has inbuilt antennas, external, or it's a distributed antenna. So we can say that 0 means a built-in antenna. So as you buy these devices from the seller, you just look at the number at the number or the ID of this access point described on the package, and you know that that device has inbuilt antenna, or it has outbuilt or external antennas. And then the digit here, the 5 means the product evolution. Which technologies does it support? Okay. If it is 5, it can be upgraded up to the SC, which is the newest technology for the wireless standards products. But if it is below 5, like it has a 1, a 2, or a 3, then also that means it supports some technologies which cannot be upgraded. For the 0 in this category, it will mean that you have to know the industry, okay? Whether it is reserved for various generation. Like for the 2.5 gigaport parts, it can be available there. Then for the D signifies which frequency band it supports. Mainly if it's a dual frequency band or 3 frequency bands or a single frequency band. Mainly, it is advisable that you get an access point that supports dual frequency band or trio or the 3 frequency frequency bands. The N, okay, the N will signify that you have whether you have the gigabit ports in uplink form or you do not have them in uplink form. And sometimes you'll find that some of them will have the E kind of type. Now, this is the 7050DN is one of the newest access points on the market by HUAWEI, and for it has the enhanced version of these ports for the uplink. You can have them in the uplink there. APs significantly mean access point for the enterprise network that give you Wi-Fi. So that is just to describe the various meanings of these categories of access points there for you. So we have various families of these access points. Like I said, there is indoor access points, there is outdoor access points, and each of them has various statistics or specifications. Right now, if you are into business, there are two new access points that you could use that could wow your experience when you're using the wireless network. That is the 6050DN access point and the 7050DN access points. You do not need to be on a cable network to have this experience because they give you better speeds. Just imagine having a wireless access point that can give you the MIMO technology that you normally use on your phones for connectivity of voice, but also giving you speeds of 1.7 gigabits per second. You know, those are crazy speeds within the wireless networks. Supporting you with uplink of 2.5 gigabit port, really, that's great for experiencing. And then for the 6050, which is mainly recommended for businesses out there. There are other new or there are other access points depending on the specification and also the amount of money that you're willing to spend on your network. And also, most of these support eSite, which is a very good application for the wireless network. We have outdoor antennas. Outdoor antennas have also various series, and they come now. The newest version is the 802, the 11C technology outdoor antenna technology, which is much more used to give you better speeds for their surrounding areas. Most of them have got external antennas. Actually, it is recommended that all of them have external antennas for the outdoor, and some of them have got inbuilt antennas. Like the 830DN access point, which gives you speeds of a maximum of 2.4 gigahertz, and also supplying you at 5 gigahertz, reaching speeds of 450 megabytes per second, and has got the capability of power over Ethernet supply. It has the optical port, which you can use the fiber optic cable to connect, and also has dual Ethernet ports for you to have connectivity in case you don't have fiber optic. It supports a dual network port, which gives redundancy. When you supply your access point, in case one of the lines of the network is off, it has that redundancy port where you can connect another network line for you to be connected always without failing. So those are some of the categories of these access points, both for outdoor and indoor. The specifications are just there. But we have another family which we call the agile distributed access points. This one gives you very good experiences in case you need to connect very many devices, but also having different capabilities. For example, if you look at the 9430 access point, which is the agile distributed, that's why for them you see the AD, not AP. It is the AD, which means Agile Distributed Access Point, having a minimum number of users to support, but it can support up to 500 users. The master of all these access points for the Agile Distributed, we have the AD9430 DN 24 version, which supports up to 1,000 users, okay, concurrently accessing the network. Because most of the people complain my access point can only support 10, mainly the MiFis. You guys buy MiFis that can support only 10 users, which is approximately equivalent to your phone giving Wi-Fi. Also, your phone can support up to 10 users. Most of the phones, actually, not all of them. Some can support up to 4, some 5, but most of the smartphones can support up to 10 users. But just imagine an access point supporting up to 1,000 users connected to one device, okay, and giving them very good speeds of approximately, they can give a speed of approximately 400 megabytes per second, working both for 5 gigahertz and also 2.4 gigahertz per strum bands. So that is really something for the Agile Distributed Access Points. So when you're making a choice in choosing which access point I'm going to go for, you can choose whether indoor for the particular conditions, or you can choose to go for outdoor. If you really know what you are really running for, you can go for the Agile Distributed Access Points there for you. So those are the products, some of the products. I remember these were some of the questions that someone was asking me. Are you going to look at some of these applications and all that? Yes, these are some of the applications that we have looked at, and those are some of the devices that Huawei has on market as of now in 2020. So the applications, and this is where we're going to look at some of the applications, whether indoor or outdoor. The access controllers are used to manage your devices, the access points. So we have an access controller connected to switch, and we have various access points connected to those switches and then controlled entirely. Though you can also connect directly an access point to the AC, and this AC will manage. So you do not need to come and configure these access points. You just have to control all of them on the AC. You can just go mount these access points in the various directions and sit only at the AC to manage whatever you want to control on those access points, wherever they are. So that's how the ACs work. So we can have access points mounted for indoor. We have already looked at classroom, open area, offices. We have also the distributed access points that work in hotels, airports, and all that. Yesterday we saw one of the videos for the airport, and I've already also uploaded it on Telegram. You guys can review that video. For outdoor, there are government agencies like the police. I haven't seen Uganda police implementing wireless networks in its centers, or maybe I haven't visited that many. The people who have been there will tell me whether you have Wi-Fi, free Wi-Fi at these police stations. People will be telling me about that. But the outdoor access points are very much key to be deployed in high power outdoor areas to give coverage performances that could be affected by also transmission powers. Antenna types could also affect the performance. The height at which you install these access points will also matter, but also if there are obstacles in that area that will cause the blockages or the obstruction of these signals from reaching far ends. So those are some of the factors: height, obstacles, antenna gain, transmission power, but also the antenna type. Sometimes you don't need to install omnidirectional, you just need to install bidirectional antenna to order to achieve the best performance through or from that access points that you are installing. Then for network management, that's where we see the HUAWEI eSite